Grade 12, grade 11s, and metric rewrites. Whenever you are, wherever you are, welcome to paper 1 functions, part 2. I am Nation. In this video, we're going to be covering sketching a hyperbola and sketching an exponential function. Enjoy. The next graph we are sketching is a hyperbola. Let's follow these 3 simple steps. So how to sketch a hyperbola? Firstly, this graph is generally defined by this equation. Y is a over x minus p plus q. So we first need to understand what p and q represent. So they represent what we call asymptotes. These are the dotted lines a graph is not allowed to touch. Call them don't touch if you like. We have a vertical asymptote and a horizontal asymptote. From the equation itself, vertical asymptote, we are actually referring to the value of p. So that's going to be the vertical asymptote. That's p. When you look, guys, at the y-axis and x-axis, a vertical line will touch the x-axis. Therefore, this vertical asymptote, which is p, actually represents the x value. We also have the horizontal asymptote. Horizontal asymptote, which is actually the value of q right there. And in the same way, if you draw a horizontal asymptote, it's going to be cutting through the y-axis. So the horizontal asymptote will represent the y value. Now, so when we sketch, 3 steps. Step 1, we must start by predicting the shape of our hyperbola. So that's going to be the shape, and the shape will be determined by the sign of a. If a is a number which is greater than 0, that's a positive number. In your asymptotes, ladies and gents, in your asymptotes, the hyperbola will appear in the first quad and reflect in the third quad. And if a is a number which is less than 0, that's a negative number, then in our asymptotes, the hyperbola will appear in the second quad like this and reflect in the fourth quad. Okay, so now when you refer to this example here, we can already see that, okay, a is a negative, so we'll see what will happen when we get there. That's the first thing. We predict the shape according to the sign of a. Second step. In step 2, we remember that a graph is a relationship between x and y. Therefore, it may cut the y-axis and it may cut the x-axis. So in step 2, we find the intercepts with the axis. Starting with either one, we can just start with the x-intercept. At the x-intercept, we let y equal to 0. After that, we find the y-intercept. And at the y-intercept, we just let x equal to 0. After that, once we have our intercepts, we proceed and go to our final step, which will be sketching. That's step 3. We are just going to be sketching. So we are talking about the shape, then the intercepts with the axis, then we sketch. Let's go to our example right here. So this example, okay, let me just write it bigger. We have y is -2 over x minus 3 plus 3. So when we start, so that we can predict the shape, let's recognize the asymptotes first. So the asymptotes. We need to write the x asymptote and the y asymptote. According to our equation here, the general equation, we must write P and Q. So P and Q here, we are talking about the x value. When you solve the denominator here, you simply change the sign. X is going to be equal to 3 and y will be this 3 right here, positive 3. So both of these, we call them equations of asymptotes. Now, step 1, now we start. We predict the shape first of the graph. Shape, you go to your equation and you look at the sign of A. Now remember here, our A is equal to -2. That is a number which is less than 0. So since A is a negative number, in our asymptotes, the graph is going to appear in the second quad and reflect in the fourth quad. At least we know this is how it's going to look like. Now, what's missing? That will be the next step where we find the intercepts with the axis. Let's start with the x-intercept. We let y equal to 0. Let's do that. In our original equation right there, where we see y, we're going to be putting 0. So the whole expression here is going to be equated to 0. So we are talking about -2 over x minus 3 plus 3. Everything is equal to 0. Then we solve for x. To solve for x, just remember what we learned in grade 10 and 11 about solving an equation with fractions. One of the methods to use will be cross multiplying. So to prepare for cross multiplication, we'll take +3 to the other side. It will become -3. Now remember, it's negative but 3, but it's actually -3 over 1. This makes it easier to cross multiply. So this -3 will multiply everything here. So we are talking about -3 multiplying x minus 3, and then -2 times 1, that will be -2. At this stage, it's up to you how you prefer to proceed. I'm going to remove the brackets. So -3 times x will be -3x. -3 times -3, that's a +9, is -2. Let's take 9 to the other side. That's going to give us a -2 minus 9, which is -11. Then we divide both sides by -3 because we are solving for x. So therefore, x must be the subject of the formula. -3 cancels out -3. We are left with x. And here, that's just going to be 11 over 3, which we can actually write in decimal fraction as a comma so that we can locate it on the number line when we sketch. That's going to give us 3,67, rounding off to 2 decimal places. So as a point, we're going to write, okay, this is our what? Our x-intercept where y is 0. So the x value, we found it to be 3,67 and y is 0. So we are done with the x-intercept. Now let's get to the y-intercept. Okay, the y-intercept. Now the y-intercept, we're going to let x equal to 0 in the original equation. This is our original equation. Where we see x, we are not even joking. We are putting 0. -2 over, in the place of x there, that's going to be 0 minus 3 plus 3. We use our calculator to see what we are getting. In fraction form, we are getting the same value as the one we got for x. So that's going to be 11 over 3. Written in decimal form, that's going to be, again, 3,67. As a full point, we're going to write, therefore, when x is 0, the y value is 3,67. So we have everything we need, ladies and gents, here. We have, let's see. We have the equations of the asymptotes. We have the x-intercept, and we also have the y-intercept. Let us sketch. Now to sketch this, we're gonna need our y-axis and the x-axis. So let's label them. It's very important we don't forget to label this. So that's y-axis, and x-axis here is gonna be 0. And remember, guys, when we sketch a hyperbola, it's always advisable to start with the asymptotes. Asymptote at x is 3, and another asymptote at y is 3. So let's do that. We need our dotted lines at x somewhere here. The first asymptote is at x is 3, right here. The other asymptote will be at y is also 3. Right here. Then remember the shape we predicted in the asymptotes. The graph will be appearing right in the second quad and reflecting in the fourth quad, since a is a negative number. This is the second quad of the asymptotes right here. This is the fourth quad of the asymptote. So we're just gonna curve it like this, approaching the asymptotes but not touching the asymptotes. So this is gonna be its reflection in the fourth quad. Nazo, not forgetting that the y-intercept is at 3,67, as well as the x-intercept is also at 3,67. So this is our hyperbola, and checkmate. Next customer, please. Let's try this one out. you may pause the video and try it first. Okay, we're going to be following 3 steps once again here. We start with the equations of the asymptotes. So we need the x value asymptote and the y value asymptote. So the denominator again is x minus 3. So we solve for x right there. We're going to get x is positive 3. You just change the sign. And this number right here, that will be the y value, which is 4. So once we are done with the asymptotes, we proceed to predict the shape of the graph. The shape is always determined by the sign of A. So in this case, A is equal to 4, and 4 is a number which is greater than 0. So when we sketch our graph in the asymptotes, since A is a positive number, the graph is gonna be in the first quad like this and reflect in the third quad like that. I like that. Okay, now what's next will be the intercepts with the x's, starting with the x-intercept. This is the place where we let y equal to 0. You go to your original equation. In the place of y, you write 0. So the whole expression is going to be equal to 0. So that's going to be, okay, 4 over x minus 3 plus 4 is equal to 0. We take 4 to the other side to prepare for cross multiplication. Four will become negative 4, which we can also write as negative 4 over 1. And then this negative 4 is going to be multiplying this whole denominator right there. So that's negative 4 multiplying x minus 3. Then 4 will multiply 1, which is 4. So negative times x, that's going to be a negative 4x. Negative times negative 3 is a positive 12 is equal to 4. Negative 4x, let's take 12 to join 4. That's going to be 4 minus 12, which is negative 8. At the end of the day, we're going to be dividing both sides by negative 4 to make x the subject of the formula. So when we cancel out here, we're going to be left with x on the left. And then here, that's going to be a positive 2. Remember, this is the x-intercept. An intercept is a full point where y is equal to 0. So our x-intercept is going to be 2:0. Okay, one down. Now let's go to the other intercept, which is the y-intercept. Y-intercept. So this is the place where we let x equal to 0 to get the y value. In the original equation, let's see. In the original equation here, where we see x, we're going to be putting 0. Let's do that. We have 4 over, so in the place of x here, that's going to be 0. So 0 minus 3 plus 4. Use your calculator. Your calculator will give you 8 over 3. To write it in decimal form, we are going to get 2,67. Therefore, when x is 0, the y value is 2,67. What do we have? Everything we need. We have the y-intercept, the x-intercept. We also have the equations of the asymptotes. It's time to sketch. Sketching, we need the y-axis and the x-axis. Not forgetting to label them as such. And here we have 0. We are starting with the asymptotes. First one at x is 3. Next one at y is 4. The dotted lines. At x is 3. Okay, somewhere here. X is 3. And then at y is 4. Somewhere right there. Y is 4. Then we check where in the asymptotes are we drawing the shape. According to this, since A is a positive number, that's going to be in the first quad and also in the third quad. So here we have the first quad of the asymptotes. Nazo. So remember, the graph is not supposed to touch the dotted lines. And it's going to be reflecting in the third quad. So, but let's see where it's supposed to touch on the axis here. Okay, it's supposed to touch on 0 and 2,67. In other words, the y value is a positive number, 2,67. And also the x value is going to be a positive number, which is 2. So I'm just going to draw it accordingly, making sure it's appearing in the third quad of the asymptotes. Right here. Nazo. So this is our x-intercept, which is equal to how much? Which is 2. And the y-intercept, which is 2,67. I hope you guys got it right. This is our lovely hyperbola, ladies and gents. And checkmate. Next customer, please. The exponential function. So when we sketch the exponential function, we have to consider firstly one of the general equations. The first one is y is a to the power x. We'll do the other one later. Y is a to the power x. 3 easy steps. So the first step we're going to do is predicting again the shape of the graph. The shape. Now this is quite a unique one because unlike in other graphs we did, in this case we are not going to be looking at the sign of A, but we are going to be looking at the value of A. So we check whether A is a number greater than 1 or less than 1. So if A is a number greater than 1, the graph will be an increasing function. So it's going to curve like this. It's curving upwards. If A is a number which is less than 1, then the exponential function is going to be a decreasing function curving downwards like that. So we'll see the example when we get there. And in step 2, we are going to look at the intercepts with the axis. Actually now, in this form, guys, in this form we have of y is a to the power x. We are not going to have the x-intercept, but when we do the example, we'll show why we don't have the x-intercept, so that we don't just memorize, but we know that with understanding. So this is going to have the y-intercept At the y-intercept, we're going to let x equal to 0. There is no x-intercept. What it means is that the x-axis is going to be acting as a don't touch line. It's going to be acting as an asymptote, which is actually the horizontal asymptote. Okay, now let's look at this example. You see the steps are easy. The shape, then the y-intercept. So this example here is y is equal to 2 to the power x. Let's predict the shape. So in the place of a, we have 2. So a is equal to 2, and 2 is a number which is greater than 1 according to these steps. When we sketch the graph, since a is bigger than 1, it's going to be curving upwards, an increasing function. After the shape, we go to the y-intercept. Now with the y-intercept, we let x equal to 0. So let me just write again. The original equation is y is equal to 2 to the power x. In the place of x, we are going to put 0. Anything to the power of 0, even your calculator will tell you 2 to the power 0 is equal to 1. As a full point, we'll say, okay, x is 0, y is 1. Now let's understand why this graph will not have the x-intercept. So why no x-intercept? When we write it in this form, y is a to the power x. Okay, so remember the original equation is y is equal to 2 to the power x. And at the x-intercept, we must let y equal to 0. So where there is y here, we are putting 0 to solve for x. Solving for x, when x is an exponent, we can either make same base on both sides. In this case, of course, we cannot say the base of 2 to the power anything and get 0. So we either make same base, which is not possible here, but the other option is to convert the exponential form into a log form. An exponent, which is x here, an exponent is a log in grade 12. If you are doing grade 11, just know that, okay, no x-intercept, it stops there. But with the grade 12, let's just have some fun just to show that we are not going to have any solution here. So x is equal to a log. Once a base, always a base. The base in the exponent is the base in log form. So the base is 2. This empty space here is 0. So we have log of 0 base 2. Use your calculator. You're going to get error. So here we are saying, okay, there is no solution. It's not applicable. The graph will not touch the x-axis. Let's sketch and see. So we have everything we need, which is actually what? The shape and the y-intercept. So to sketch, we need the y-axis and the x-axis. So let's label them as such. So here is the y-axis, here is the x-axis, here is 0. So this graph is going to cut at 0 is to 1. So the y value is 1 and 1 is above 0. So that's why this graph, guys, is not going to be crossing over the x-axis. It will never get under the x-axis. It will remain above the x-axis because the x-axis is acting as the asymptote of this graph. So the shape, remember we predicted it already, is going to be curving upwards like that. So let's do it. nazo, making sure we label our y-intercept as 0 is to 1. There is our lovely exponential function, and checkmate. Next customer, please. Pause the video and try this one out. Same steps, guys, for exponential function. So step 1, remember, we need to predict the shape. To predict the shape, we look at the value of a. Remember the general form, where is it? Here it is. The general form we have y is a to the power x. So we consider the value of a, whether it is a number greater than 1 or less than 1. So in this case, a is equal to 1 over 3. 1 over 3 is 0, something, which is actually a number less than 1. So when we sketch this graph right here, it's going to be curving downwards. It's a decreasing exponential function. We already know we're not going to have any x-intercept. We just go straight to the y-intercept, where we let x equal to 0. We take our original equation. There it is. Y is 1 over 3 all to the power x. So in the place of x, we put 0. Anything to the power of 0 will always be what? 1. Therefore, the y-intercept 0 is to 1. No x-intercept, let's sketch. The y-axis, the x-axis, we label them as such, y and x, 0 here. So our graph is going to be cutting through 1, that's above 0 there. And the shape, we predicted it already, here it is. It's going to be curving downwards. Like this. And it's touching the y-axis at 0 is to 1. And checkmate.